Welcome to our STS, have a look around. We're here to tell you how Copernican model is found. On 1543, the paradigm shift, it was discovered by a Polish astronomer. Welcome to our STS, take a look and see the sun's in third model for us to learn the universe. From the Earth, other planets that orbits all around the sun, and of course they orbit in elliptical move. Welcome to our journey in Copernican revolution. Today, we will witness the different people who paved the way and contributed for the development of the intellectual revolution throughout the history. So, let's start first with a little background. Copernican revolution was a paradigm shift from the geocentric understanding of the universe, which is the Earth as the center of the universe, to the heliocentric model with the Sun at the center of the solar system. Now, what are we waiting for? Presenting to you the 5 scientists who contributed to the intellectual revolution.
Salutations! I am Claudius Ptolemy, a mathematician, astronomer, and geographer of Greco-Egyptian origin who lived in the 2nd century AD. I am renowned for my remarkable contributions to astronomy and geography, particularly my geocentric model of the universe. This model was deemed influential for centuries since it accurately predicted the positions of celestial bodies and was widely accepted as the most predominant view of the universe until the 16th century. It profoundly influenced people's understanding of the cosmos and their place within it. My most celebrated work, the Almagest, is a comprehensive mathematical and observational treatise on the motions of the stars and the planets. In geography, my work, Geography, served as a guide for map making, which was instrumental in creating precise maps of the world that greatly aided navigation and exploration. My maps were among the most accurate and detailed of their time and were used for centuries after my death. My contributions to science and technology left a significant impact on the society. The precise maps and navigation tools that I created helped expand trade and exploration, leading to a great cultural exchange and economic growth. Overall, my accomplishments help expand knowledge and understanding of the world and pave the way for future scientific advancements. They also played a significant role in shaping society's perception of the world and our place within it. I am proud to say that I was the sole great astronomer of Roman Alexandria. I will finish my story by saying, well, do I know that I am mortal, a creature of one day, but if my mind follows the wandering path of stars, then my feet no longer rest on earth, but standing by Zeus himself, I take my fill of ambrosia, the food of the gods.
I am Nicholas Copernicus, a Polish astronomer and mathematician who is best known for my groundbreaking work on the heliocentric model of the solar system in 1543. I published my major work entitled De Revolutionibus Orbium Celestium, or On the Revolution of the Heavenly Spheres, which laid out my heliocentric model in detail. The impact of my heliocentric model on the society was profound and far-reaching. First, it revolutionized scientific understanding. The Copernican model challenged the prevailing geocentric view of the universe, which had been dominant for centuries. By introducing a new model that placed the Sun at the center of the solar system, I sparked a scientific revolution that eventually led to a more accurate understanding of the workings of the universe. Second, I challenged religious beliefs. The heliocentric model conflicted with the traditional religious beliefs of many people who saw Earth as the center of creation. This caused controversy and sparked debates over the relationship between science and religion that continue up to this day. Third, I encourage scientific inquiry. My work in heliocentric encourage other scientists to question, establish beliefs, and conduct their own investigations. This led to a surge in scientific discovery and advancement in the fields like astronomy, physics, and mathematics. My contributions to science were not only limited to my heliocentric model. I also made important contributions to the fields of mathematics, optics, and economics, and my work on the length of the year was highly influential. Today, I am widely regarded as one of the most important figures in the history of science, and my ideas helped to usher in the scientific revolution of the 16th and 17th centuries.
I am Tycho Brahe, a Danish nobleman who was born on the 14th day of December in 1546. I am known for my greatest and significant contributions on science and technology. First, King Frederick II of Denmark built me an observatory to measure the positions of the planet. However, telescopes had not yet been invented, so I devised the most precise instruments available before the invention of telescope for observing the heavens. Second, I proposed a model of the solar system that was intermediate between the Ptolemaic and Copernican models. It had the Earth at the center, and it was the most widely accepted model of the solar system at the time. Third, with my new measuring devices, I was able to record the positions of the planets with the best possible accuracy for naked eye observations, 10 times more accurately than people had been getting until then. My contributions have been incredibly significant and far reaching. It helped in our understanding of our universe and our place in it through space exploration and discovery. My contributions to the society are vast and varied, and it had impacted every aspect of human life. I am Johannes Kepler, a German astronomer, mathematician, astrologer, natural philosopher, writer in music, and key figure in the 17th century scientific revolution. I am best known for my laws of planetary motion and my books, Astronomia Nova, Harmonious Mundi, and Epitome Astronomiae Copernicanae. My works also provided one of the foundations for Newton's theory of universal gravitation. Between 1609 and 1619, I published one of my famous accomplishments, which is the Kepler's laws of planetary motion, or the three laws of planetary motion, describing how planetary bodies orbit the sun. The laws modified the heliocentric theory of Nicolaus Copernicus, replacing its circular orbits and epicycles with elliptical trajectories, and explaining how planetary velocities vary. We described 1. How planets move in elliptical orbits with the sun as a focus. 2. A planet covers the same area of space in the same amount of time, no matter where it is in its orbit. And 3. A planet's orbital period is proportional to the size of its orbit, its semi-major axis. My laws of planetary motion mark an important turning point in the transition from geocentrism to heliocentrism. We provide the first quantitative connection between the planets, including our planet Earth. My laws are used in many fields, from astronomy to engineering, but even more. We mark a time when the important questions of the times were changing. The usefulness of my laws extends to the motions of natural and artificial satellites, as well as to stellar systems and extrasolar planets. Mentioning how these laws are used in the real world can help students see our relevance. Apart from my contributions to astronomy, I laid the foundation of modern optics. Among other things, I formulated the inverse square law governing the intensity of light. I invented an improved refracting telescope, and I correctly explained the working of a human eye. As founder of celestial mechanics and optics, I am considered as one of the most influential scientists in history. I am considered as one of the most significant representatives of the scientific revolution of the 16th and 17th centuries. I am Galileo Galilei. I was born on February 15, 1564 in Pisa, Italy. I am an Italian natural philosopher, astronomer, and mathematician who made fundamental contributions to the sciences of motion, astronomy, and strength of materials, as well as the development of scientific method. My formulation of the circular inertia, the law of falling bodies, and the parabolic trajectories marked the beginning of a fundamental change in the study of motion. My insistence that the book of nature was written in the language of mathematics changed natural philosophy from verbal qualitative account to a mathematical one in which experimentation became a recognized method for the discovery of the facts of nature. Finally, my discoveries with the telescope revolutionized astronomy and paved the way for the acceptance of the Copernican heliocentric system, but my advocacy with that system eventually resulted in an inquisition process against me.